Hello everyone, welcome to Learn Overflow. In this video, we'll discuss one of the important LeetCode problems, that is the longest increasing subsequence. So this is a medium level problem and we'll understand what this question is asking us to do and how we can think of solving a question like this and how we can actually easily find a solution to this kind of question. Okay. So before starting this video, make sure to subscribe to Learn Overflow if you haven't subscribed to this channel already for regular LeetCode videos like this. So let's understand what this question is asking us to do. The question says we are given an integer array nums, that's the integer array num given to us, and ultimately we need to return the length of that long case strictly increasing subsequences. Okay, so if you don't know what the subsequence is basically if there are like array like this 0 3 1 6 2 2 7, then a subsequence is like 3 6 2 7. It's like we took a length of this and out of this we just erase this 1 and 1 2 like this. So 3 6 2 7 is a subsequence. Okay, but the example given here is not an increasing subsequence. Why so? Because 6 is like 6 is less than like greater than 2, so it's not increasing, it's decreasing. It's like a normal subsequence. Okay, so that's a subsequence, so it can be taken from any place. Okay, so that's the idea over here. Now let's understand this example. In the example, it's like it given an array to us, and it says that the length of the longest increasing subsequence is 4, and length is what? It says like 2, 3, 7, and 1, 0, 1. So it's more or less like, see, the length goes from here till here, and in between, if you either take 3, it's like length 4. Yeah, or in the other case, if you take 5 and don't take 3, then it's also length 4. So you have two options, and either way, the length is 4. So there you can understand that there can be multiple subsequence possible, that is in strictly increasing subsequence possible of the same length. Okay, that is the longest length, but you need to keep a track of only one length. So that's enough for us. Now look here, the question is not like this. Question is like, say there's like 2 5 and 3 is there. Fine. If a array is given like this, in that case, what can be our longest subsequence? It can be say 2 5, either 2 5, or it can be 2 3. Fine. So after, when we look at this two elements 2 5, then we're trying to put in 3. Okay, now we are actually in a state of confusion. State of confusion is the confusion like what we will do. Should we replace 5 with 3? Like, should we take this one, or should we go ahead with this one? Okay, like, should we keep 5 and continue with the subsequence, or should we remove 5 and replace 5 with this 3, so and continue with the with our particular particular array length, or the length we are going at. Okay, so once it's a length of 3, like only 2 5 and 3 are there in our array, the array length is 3. There we are not bothered much because that's the maximum length is attained in any other way. Fine. Say in the next case we come across another one. Okay, if we come across another one, then there's like 2 5, we cannot take 1. If we take 1, we are in a confusion like its length is going up or going down. Okay, and then if we look like 2 3, and if we include 1 over here, still we are in a confusion, like we are not sure if its length is going up or the length is going down, because till 1 we if we include 1, our length remains same, but we need to see if there are other elements after this or not. Fine. So that's the question over here. So if it's a length 4, then we know like 2 5 2 3 or 2 1, either one is like a solution to our given question. Fine. But the question comes, we are not sure about the total length given to us. Okay, we are not sure which of the particular element to take and which one to leave. Now say after this one, if there are other elements like 2 3 4 5 and 6, if this was our whole array, now what we'll do, can we take anything from the first 3? Like, if we take anything from the first 3, it will be a waste, because if we start from 2 and then go to 5, if we go to 2 then go to 5, then what we're left with after like 2 5, if we take on the first 2, then we can only take 6, that is at the last. That's our length, that giving us a length of 3. Okay, if we take 2, the first 2, and then we take 3, then we take like 2 3 from the first instance, and then we can only take the 3 elements at the last, that is a 4 5 and 6. So this 3 can only be a possible case, but that gives us a length of 5. Fine. But look carefully, the question is, it becomes hard, like question becomes a bit tricky, not hard, in this format, that once we leave all the three elements from the beginning, we are left with, see how many elements, 1, 2, 3, 4, 5, and 6. So if we are left with this, we are getting a length of 6 elements. Okay, so that's become the longest strictly increasing subsequence, and thus the answer becomes 6, right? So in this case, what our idea is, say, just go back to the basics, the first three elements. We had 2 and 5, and we had 3 being added. So we find the 2, 5 and 2, 3 being the two possible cases. Okay, now once we add 1, where do we actually need to check? We need to check at the smallest element. Okay, we need to check at the smallest element. Like if we eliminate the smallest element with our current element, then only we can go ahead and get a track of the rest of the element, right? If we replace one, like replace this particular one at this position with our two that we have initially taken in consideration, if we replace that, then only we can find a solution. That's the actual solution. But the question is it always that we should replace it? The answer is no. We cannot confirm, we cannot say it for sure that if we replace this particular one with the two that we initially took in consideration, it will always be a greater solution. That we cannot confirm. So the question comes in this way, that we should always keep a track, and we should always keep a check that whether taking a value or taking a next number in our consideration or not taking a number in our consideration, it helps us in which way? Like, is it either helping us or is it making a loss for us? Okay, so that's the total understanding of the question. Now, once we try to solve questions like this, there can be ways like you keep a track of, or say you go ahead with a dynamic programming approach where you keep a track that this was our previous element, this was the length we found. Starting from 0th index, we can reach a length of 3. Starting from 1th index, we can reach a length of some length. Starting from second index, what length can we reach? So we can do that with a dynamic programming approach, like not directly from the starting, but directly from the back of the, like starting from 6, what can be the length? What can be the length we can reach? Anyways, we cannot go a length beyond 1, so that's one length. Starting from 5, what can be the length? Is it increasing? If it's increasing, we should check the length possible from that index, and we should go ahead. It's like 2 possible. So we can go ahead with something like this, and we should keep a track. Like once we don't find that it is increasing, it's like decreasing. After 3, without this 4, there was a 2 over here. Fine. So it's decreasing. So we will not check for 2. We will check for the next element. Like we keep on checking. So that can be an approach. Okay, that can be an approach to go ahead with it. But in this question, there is a concept that lies, that I think everyone should keep a note of, or know of this concept. Is like the concept of tails. Okay, so let us erase this off and let me discuss the concept of tails. So tails is like tails. Okay, so tails is like an array that stores the smallest tail of an increasing subsequence in the length of, like, if the length is I plus 1, then tail of I will store the smallest element in the increasing subsequence. Okay, so this is a tails concept. Like how it works, say there are like an array is given, array like 4, 5, 6, and then 3. These are the 4 elements in our array that is given to us. Fine. If the length is 1, okay, if our length is 1, in that case, what can be what can be the elements that we can go ahead with? So the element can be 4. That is a unique element. Okay, I'm only checking for length 1. Fine, 4. Then 5 can be a unique element of length 1. Then 6 can be element of length 1, and also 3 can be a length of 1. Okay, so it's like consider them all unique elements, and they are like different elements. So if we are going with tails 1, so then tail of 0, okay, like in our array, tail of 0 will store like 3. 3 in the sense, tail of 0 will store 3, that is, it will store the smallest element. Okay, so that's the idea. Now what will happen, say in the next step, we'll go ahead with the length of 2. Okay, if we go ahead with the length 2, then 4 and 5 can be a possible case, we are just looking for the two. If our maximum length can be attained is 2, we are looking for those elements. Okay, so 4 and 5 are possible, 4 and 6 are possible, and 5 and 6 are possible. But we will not go ahead with that. We will go ahead with simply like 4 and 5 are possible, and the other case is 5 and 6 are possible. Obviously 4 and 6 is also possible, but we're not taking that because 4 and 6 we are that comes in a 3 equation, like of length 3 that falls. So we are just ignoring that for now. So let's see, we just found 4 and 5 and 5 and 6 are like longest increasing subsequence in our tails. Okay, in that case our tail of 1, fine, tail of 1 becomes what? Tail of 1 becomes the 4, tail of 1 becomes a 5. Okay, that stores the, as well as it's like the stores the smallest tail of the increasing element. So what's the smallest tail that the ending? Okay, the 4 5, the tail of this is 5. Okay, and 5 6, the tail of this is 6. So what is the smallest tail? The smallest tail is 5. Okay, so that's being stored in a in our particular tails array. Now, similarly, if it goes ahead with tails of 3, fine. How our tails array will store? It will store a value like 4, 5, 6, the one we are ignoring in the length 2. So 4, 5, 6 will be our whole array that is being stored, like that will be of length 3, right? So what is like tail of so in that case tail of 2 will be there. Okay, so tail of 2, because it's like you can see like if our length is 1, it should be like -1. Okay, so that way, so tail of 2 will be what? Tail of 2 will be 6. Okay, so I hope this is understandable, like what we are trying to find out in this way. Like it should be the smallest tailing element, like the last element that is the smallest. If it's of length 1, the smallest one is 3. If it's of length 2, the smallest last element in our array is 5. If it's length 3, the smallest last element is length 6. Fine, we're storing this. So in this case, we can easily prove that the tail is an increasing array. Fine, that can be proved. So therefore, it is possible that we do a binary search on this tails array. Our tails array is basically this array, remember. So this is the array we are creating out here. So we can do a binary search. Now, if you remember, like there can be two ways you can, like what we'll do in the binary search. Okay, we can do a binary search in the tails array to actually find out the one, if it needs an update in our tails array or not. Like the smallest one is 6. Okay, so in 4 5 6, the smallest last ending element is 6. So 4 5 6 is already increasing. We know like 5 4 5 is increasing, 5 6 is increasing, so the smallest last element is 5. So if we are trying to add something, then is it a good idea to add something over here? It's always a good idea to add something in the smallest element. If I'm adding 7, so it's always a good idea to add something in the smallest one, so that you know that like the sequence keeps on increasing. But if we can definitely add it here, because you see that the sequence keeps continuing in a proper manner. But why we'll always go for the smallest one? The idea is the tails idea. Like we are always, the tails concept, as I said, is like the storing the smallest tail, and we are trying to know like that being our last element. We can go ahead with merge elements. We can go ahead with, like, the concept is going in a process that we can go ahead with 6. If needed, we can have 6 or other elements in the possibility, but we are keeping track that the last smallest element is the 5. So that's the idea. Okay, so we can definitely do a binary search in this tails array, and we can know that if this needs any update or not. Fine, so if you know, binary search is basically we will do to find out the position, whether we should add anything or not. Fine, so that's the idea. Now what we will go ahead with this, we'll check for like we can do binary search by can like do it two ways basically. So we can do it directly defining our own code, or we can use the arrays.binary search, like the particular arrays.binary search is a function that is being provided in our arrays class, java.util.arrays. So you can use that also, so that will return us the index as well. So that's the main idea. Now when you do each time when you do binary search or some or with like either arrays.binary search or your own binary search, now what will happen, will be given with two cases. Okay, we'll be given two cases, that our current element, that is the current element in our array. Okay, like the original array given to us. So current element in our array will be larger than the tails. That can be a possibility. Like the current element says is 7, not 3, it is 7. So it may be the larger than all the tails, that is larger than our 7 6 is larger than tails. So in that case, what we'll do? We'll append it. Tails of 3, we'll append it. That's being our largest element. Fine. Because when it tails of 3, that is a length 4. We are going with a length of 4. So the smallest, largest, or that I mean the smallest tailing element in our tails array will be 7. We can add it. So we can directly append it, and we can note the size of the tails. Okay, we need to keep a track of the size of the tails. Why is it so? Because initially the tails will be of length equal to the num's length. Okay, but our ultimate increasing will not be always the same, because in some other case we may find that the increase in the tails is not different. I'll tell you the case. The first case is when you find an x, like find our current number, like the current number that is 7. We can find that this is larger than all the tails we have till now, and we'll append it and increase our increase our size of the tails. Okay, now this may not be the case. This, it may happen like the case given, like it may happen like this, like 3. Okay, so if it is like less than this, then we need to find the tails of I minus 1 and tails of I, like between which two elements this will fall. Okay, it will be less than equal to I and greater than I minus 1. Okay, we need to find between which two element it will fall. So it is 3. So 3 is like it lies between like less than equal to tail 0. So once we find the small, like find that this is the smallest, so we'll update that. So it's like 3 is initially we found it till 0, but once we say we find 2 out here, the next number being 2. So in that case we'll find that 2 is like less than equal to 3. It's like less than equal to 3, and before that there's nothing else, so less than equal to 3. So in that case we'll update 3 with 2. So that's the idea. Now doing so will maintain the tails variant. Okay, so we'll maintain the smallest in all case. Fine. Now in that situation, what we'll do, we will the final answer will be not these things, not this what's 2 was 5, or that's what's 6, or that's 7. This is not the answer. The final answer is like how much we can exchange the tails array. That's the size of that is the final answer. Okay, let me just write down this code again. Like it's a short code. Okay, let me just write it down, and then I'll make you understand this further better. Like just remember the concept. As I said, like if it's equal, larger than all the tails, we'll append it. If it's like it is less than equal to some tails, like lies between some two values of the tails, we'll update the tail size. Okay, so that's the idea. Now let's do it easily. So what it will be like? It will be like order of n log n. N being the length of this nums array. Okay, so we need to go through all the elements of the nums array. So anyways, it will be order of n. Now you can do a binary search. So I will go ahead with writing own binary search finding. So in that case, it will be like log n. Binary search is takes us a log n time complexity. Fine. So that's the whole idea. Let me just simply write the stuff for you, write the code for you, and then you will understand how this is going at. So we are not bothered with the contents of the tails array. We are rather bothered with just the length we can reach in our tails array. So let's go ahead and write that. Fine. So this is the solution for us that runs for a 3 millisecond solution. Let's see what exactly we did. First, we just took our tails array, fine, and we took our size. So size being the final answer that we are returned over here, fine. So that's the size we have. Now let's understand this. So we took all the elements of like we went through like for each elements in nums array. That's x. We took it as x, fine. Now next thing we did, we just took it I being 0 and j being size, like till the length we reached till now being why j being size. So in that case, we keep a track of all the elements in our tails array that are till like those are the elements being inserted by us, not those like auto field 0 value that comes when we just declare declare our array. So not that value. So we're just mentioning the start and the end. Now we're checking while I not equals a. That means while we keep on traversing the low and while we don't find the value. Okay, now is like the middle value is I equal j plus I plus j by 2. So this is where the binary search is going on. Fine, we're just checking if our tails tails of m, like tails of middle value, is less than our x. Okay, if our tails of middle value is less than our x, that is, it lies in the left hand side. So we are just moving our I to m plus one. Fine. In the else case, we are moving our j to m. Fine. That's the idea. Now, this is the binary search, the similar kind of binary search approach. And in the after that, we simply place our tails of I in our x. And if I is size, then size plus means what it does. Okay, I is zero, that is the left hand, and j is some size. Okay, say if I just take it something like I is zero, fine, and j is something like say 4, fine, and we come across a value that we find the mid value. We don't find like the mid value is, we find is greater than like the mid value is like less than x. Okay, so x lies something on the right hand side. In that case, I equal to I plus 1, so I equal to m plus 1. So what is m? 0 plus 4 by 2 is 2, so I becomes 3. Okay, and the next case we find that again we find I is not equal to j, so I plus j, so 3 plus 4 by 2 is like 3 again. So 3, that is x lies, say x is a greater value first case. So in that case we find that I plus 1 again happens. So what is 3 plus 1? That is 4. Fine. So I equal to j, we find, then I we place that in our tails array at some place. Okay, because other, considering the other places are filled, 0 1 2 3 are filled, so at the fourth place we insert our current value. Okay, that is current value being x being the current value we're taking. Okay, so I'm considering that these elements are filled initially, then we are checking for this one. Okay, now in the next case, if we become that I is already equal to the size was initially 4, so this was the size. Okay, I is size, then size plus 1, so size increases to 4 to 5, like this is the increment. We just keep on doing that, and ultimately we just return the size. So we are not bothered with the exact element that we take in our array. We are bothered with the length that we come across in our array. Fine. So in that case, why we'll keep track of the exact elements? We can simply do with this tails concept. Okay. So that's the whole thing we did, and we found out the how this question works. Okay. If you cannot understand this question anyway, if you still cannot understand this, then I will simply say just take a take an any example and just do a dry run. Fine. You are, remember, you are not bothered with what elements are there inside your tails array. You are rather bothered with the size, because that's the what you are returning. So if you still cannot understand this concept, I will say you just take any example and find out the length. Find out the, do a dry run and take a tails array, draw a tails array, and keep placing the elements and see what the size current value stays at. Fine. That will simply help you to go ahead and understand this better. And still, if you want, you can definitely comment down in the comments below. I'll be happy to help you out again. Okay, so that will be I'll be happy to do that. So that's more or less about this video. So I hope I can make you understand how this question works. So thank you all for watching this video. Make sure to like this video if you think this is helpful to you. I also hope to see you soon in my next video as well. Thank you all.